In our last video, we took a look at troubleshooting RIP version 2. RIP version 2 could be used to route IP version 4 networks. In this video, we're going to talk a bit about RIP-NG, RIP Next Generation. That can be used to route for IP version 6 networks. And the basic set of troubleshooting issues that we have are about the same as we had for RIP version 2. And I didn't want to read through that big laundry list of possible issues again. Instead, I wanted to take our time in this short video to show you some show commands that we could use to glean information from a RIP-NG speaking router to help us in our troubleshooting. Now, there are a few differences. For example, authentication works differently. RIP version 2 has an authentication feature that's built into it. RIP-NG is going to rely on the authentication feature built in to IP version 6. There's no concept of a classful network with IPv6, so we don't have to worry about the summarization issue that we had with RIP version 2. And also, there's no concept of a passive interface with RIP-NG. But for the most part, it's the same set of issues that we're thinking about, and I want to show you a few show commands that we can use to get some information. First, let's take a look at what the router has learned via RIP. We can peer into the RIP database with this command. We can say, show IPv6 RIP database. And these are the routes that RIP knows about. It knows about 3 different networks. However, just because a network shows up in the RIP database, that is no guarantee that it's going to show up in our IP routing table. We might have a more believable source for a network in our IP routing table. For example, if OSPF says, I know how to get to 2004:/64, well, that would be believed over this, because OSPF version 3 that we would be running to support IP version 6, OSPF has an administrative distance of 110. RIP is 120. So OSPF is more believable. Here's something that's going on in this topology. If you take a look, you'll notice that 2002::64, that's directly attached to router R1. RIP knows about it, but do you think we're going to use the directly connected route or something that RIP told us about? Yeah, we're going to go with the directly connected route because it has an administrative distance of 0. It's the most believable. So just because a route appears here, this tells us what RIP knows about. It's no guarantee that it's going to be in the IP routing table. Let's take a look at what RIP learned routes have made it into the IP routing table. We can, or the IPv6 routing table specifically. We can do a show IPv6 route RIP, and we can see that, yeah, that directly connected route was not injected, obviously, because it was directly connected, but we did learn about 2 routes via RIP. That's what the R is telling us. We learned this via RIP. And one other command I want to show you. Remember the show IP protocols command? Let me show you the IP protocols command for IP version 4 for a second. You see, this gives us quite a bit of information. It tells us interfaces participating in the RIP process. It gives us timer information. It talks about version information. It tells us our administrative distance. We see information about any filters that are applied. There's quite a bit of information here. We don't get nearly as much information if we do show IPv6 protocols. It tells us a couple of things. I can see the name of my RIP process. I named it demo, but we don't get all the information that we got with show IP protocols. With show IPv6 protocols, really the main takeaway information that I'm normally going to get from this, it's just a list of interfaces participating in this routing process. Well, that's a look at a few show commands that can help us gather some information when we're doing troubleshooting of RIP-NG.